Hello, here's the second video for our graphing of parabolas unit. Yesterday we went through and graphed a parabola with its vertex at the origin. Today we're going to start off by writing the equation of a given parabola and its graph. So what we notice first with this parabola is that it's opening vertically, downward, but vertically, which means the equation of the parabola will follow 4py equals x squared. I also notice that I'm given the focus, which is at 0, -3. According to our formulas from yesterday, the focus for a vertically opening parabola will be at 0p. So this is 0p, meaning that the p value equals -3. Thus the equation for this parabola must be 4 times -3 y equals x squared. And that's it. That's the equation of this parabola. All right, next up, we're going to be looking at an application of parabolas, and that has to do with parabolic reflectors that are oftentimes used to gather sound at sporting events. They're also used for satellite dishes for TV broadcasts and whatnot. So what we're given here is the cross-section of a parabola as if we had cut it in half for this parabolic reflector, and we want to know the equation for the parabola, but we're not given the focus this time. We're just given a point on the parabola. So noting again that this is opening vertically, I'm going to use the equation 4py equals x squared. And I'm going to plug in this xy coordinate. So my y value is 5, my x is 10. What this allows me to do is isolate the p as a variable so that I get 20p equals 100, and I now know p must be equal to 5. So my equation would be 4 times 5 times y equals x squared. And that's the equation of this parabola. I can now identify where the focus is, and that's important because for one of these parabolic reflectors we would place the microphone at the focus so that all the sound coming into it would be directed at that microphone. So noting that the focus would be at 0p, I know that this focus would be at 0.5 because my p value is 5. So I could go up to where that is and draw it in, and I would say the mic is 5 units from the vertex. There we go. Nice little application of parabolas. Next we're going to take and shift a parabola around the coordinate plane. So as I look at the given equation, I notice that it's not just y squared equals 4px. I've got some other stuff in here. And since it's y squared though, I know that this is going to be a horizontally opening parabola. And I'm also going to use a slightly different form from what we've been seeing. I'm going to incorporate this, y minus k, where k is our vertical shift, squared, equals 4p x minus h, where h is our horizontal shift. The alternate form of this, although we're not using it in this problem, would be for a vertically opening parabola, and we would have x minus h squared equals 4 times p times y minus k. So that's what I want to get this equation to read, is in that first of those two formats. So what I'll do is I'll take and write the y squared, but on the other side I'm going to factor out a 4, since that's the common factor, to give me x plus 3. Now I don't have a p-value in there yet, however, it's easy enough to rewrite it without changing it, so it's 4 times 1 times x plus 3. Now I have a p-value. The p in this case is 1. My horizontal shift is going to be a negative 3, since this would be x minus a negative 3. So my h is a negative 3. And there is no k value listed, so my k is 0. So now, from the origin, my vertex has been shifted 3 units horizontally. So that is my new vertex. It's at negative 3, 0. I will now travel p units horizontally, since this is opening horizontally with the y squared in the equation, p units to find the focus. So I travel 1 unit to find the focus, which will be at negative 2, 0, and negative p units to find the directrix. So that's going to be at negative 4. So my directrix equation is x equals negative 4. Okay, that's not what I wanted to do. Too large of an eraser there. Now let's go ahead and create a little xy table to get a couple points on this parabola. Noting that the y is the squared term, it may be easier to plug in some y values and get out the x's. So let's do that. I'm going to plug in, let's say 4 for y, and then I'll go back to maybe this first equation up at the top here. So I'm going to plug 4 in for the y value, giving me 16, which would, in order to make this statement true, x would have to be equal to 1. So I've got the point 4, 1, or 1, 4, sorry. If I plug in negative 4 for y, I get a similar result with x having to be 1. So that gives me 2 more points on my parabola. I've got the point 1, 4, and 1, negative 4. That's enough for me to sketch in my parabola. There we go. A parabola not centered at the origin. Finally, we're going to take a look at a parabola whose equation is given to us in general form instead of standard form, and we're going to rewrite it into standard form. Noting right away that the only thing that's squared is the x, not the y, I know that this is going to be a vertically opening parabola. And then I'm going to want to write it into the format of x minus h squared equals 4p y minus k. So let's start that process. We've seen general form for circles, for ellipse, and hyperbolas, and now we're going to run into it with a parabola. The process here is going to be a little bit different than the other ones in that I don't want to leave the x and y's on the same side. I want to move the y to the other side. So let's go ahead and do that. I'll have the 4x squared plus 40x on the left, and I'll have a negative y minus 106 on the right. Now, in an effort to complete the square on the left-hand side, I'm going to factor out the leading coefficient, leaving me with x squared plus 10x in the parentheses. And then to complete the square, I'm going to take half of the 10, which is 5, squared, which is 25, and add that inside the parentheses. So I'm going to have now x squared plus 10x plus 25. But in order to leave this equation balanced, I have to add that same value on the right-hand side. Now I didn't just add a 25, I actually added a 4 times 25, if you look at the distributive property. So that's what I'm actually going to have to write on the right-hand side as well. So plus a 4 times 25 on the right-hand side to keep this equation balanced. This is a perfect square now in the parentheses. I have 4 times x plus 5 quantity squared, which will be equal to, and on the right-hand side, I have a negative y minus 6. Okay, last thing here, almost the last thing. I don't want a negative here, so I'd have to factor that out. So that leaves me with a negative y plus 6. And then the 4 can't be on this left-hand side. It has to be 4p and then the y stuff over here. So let's divide the 4 out. So I'll divide each side of my equation by 4. Divide by 4. So I have x plus 5 squared equals 1/4, actually negative 1/4, times y plus 6. However, this negative 1/4 actually is supposed to be a 4p. So I have to rewrite that as 4 times something. All right, I'm going to write this up at the top here since I'm running out of space. So I'm going to write my final deal is x plus 5 squared equals, I'm going to do 4 times a negative 1/16 times y minus k. That actually gives me that 4 times negative 1/16 would be the same as negative 1/4, and I have 4 times p now, so p is a negative 1/16. Write that down, p equals a negative 1/16. H value is a negative 5, and my k value, I wrote k in there instead of plus 6, I did k. Sorry. This is supposed to be a plus 6. So k is a negative 6. All right, I now know where my vertex is. It's negative 5, negative 6, negative 5, negative 6. There's my vertex. Negative 5, negative 6. My p-value is negative 1/16, so I have to move a negative 1/16 vertically, because this is a vertically opening parabola because of the x squared. So a negative 1/16, that's going to be really difficult to draw, but I'll put it in there. So that's going to be at negative 5, negative 6, and a 16th. And then to get my directrix, I'm going to have to move up a 16th. So that's going to give me this line right here. Again, not moving up very much. That's going to be at y equals a negative 5 and 15/16. And then I'm going to plot a couple points. If I put in negative 6 for x, that's going to give me a negative 10 out, I believe. And if I put in a negative 4 for x, I believe I also get out a negative 10, just putting them into my equation here and cranking them out, or into this equation and solving them. And so then I can go ahead and graph my parabola. There we go. Good luck. Have fun.